Now let us solve one more question which employs what is called as the method of difference. Now here we have to find the sum of 3 plus 15 plus 35 plus 63 and so on up to n terms. Right. Now here if you observe that the terms are successively increasing, and let us try to see what is the difference between them, between the consecutive pair. So the difference between 3 and 15 is 12, between 15 and 35 is 20, then here it is 28 and so on. So you see that the difference itself is increasing by 8 in every step. Okay, so whenever we have this kind of situation, we use what is called as the method of difference. That is, we first write the required expression as, say, s, this is our required sum, and we write the first few terms, that is 3 plus 15 plus 35 plus 63 and so on up to say, let's call the last term as tn. Alright, now what we do is we write the same expression, that is the same series, but with all the terms shifted to right. That is, now I will write 3 below 15 plus 15 is written below 35 plus 35 below 63 and so on. Now here the term which comes below tn will be nothing but the term previous to it, that is tn minus 1, and the last term will be tn. Right. Now if we subtract the two expressions, okay, why we are subtracting? Because we have observed that the differences are steadily increasing. So therefore on the left hand side here we get s minus s is 0 is equal to the first term is 3 as it is, plus, now in this particular portion, okay, whatever differences we are going to get, see what happens. 15 minus 3, first we get the difference as 12, plus 35 minus 15, that is 20, plus the next difference is 28 and so on. Now this will go on for how many terms? It will be for n minus 1 terms only, because the first term, which is 3, is not coming into picture, isn't it? So therefore out of n terms, 1 term is left, so therefore only n minus 1 terms will be present in this particular sum, and at the end we have to also subtract tn, which is the last term. Right. So finally if we bring the tn on left hand side, therefore we will get tn to be equal to 3 plus. Now if we look at the expression which is inside this particular bracket, it is nothing but an AP, because it starts with 12 and successively the common difference is 8, and there are n minus 1 such terms. So therefore we write the formula for sum of n minus 1 terms of this given AP. So therefore we get, as per standard formula, we have n minus 1 upon 2 into bracket 2 into the first term, which is nothing but 12, plus, now in the next bracket the original formula says n minus 1, which is nothing but number of terms minus 1, but here we have n minus 1 term, so therefore ultimately we will get n minus 1 minus 1, which is n minus 2, and this has to be multiplied with the common difference, which is nothing but 8 in our case. Right. So this further gives us 3 plus n minus 1 whole upon 2 into bracket we have 24 plus 8n minus 16. So that further equals 3 plus n minus 1 whole upon 2 into bracket 8n, and 24 minus 16 is plus 8. Right. So that further gives us 3 plus n minus 1 upon, now well, we can cancel out the factor of 2, and what remains in the bracket is 4n plus 4. Right. And now when we open the multiplication of two brackets, we will get n into 4n, which is nothing but 4n square. Alright, then the n term is nothing but n into 4, which is 4n, and another product gives us minus 4n, so therefore n term gets cancelled. Now as far as constant term is considered, that gives us minus 1 into 4, which is minus 4, and when you club it with 3, you have 3 minus 4 as minus 1, so therefore finally we get the general term Tn to be equal to 4n square minus 1. Alright, so this is the expression for general term. Now since we have got the general term in terms of n, now we can proceed and get the expression for sum of n terms. So therefore sum of n terms is nothing but summation of, say, all such general terms denoted by tr, where r varies from 1 to n. Right, so that is equal to summation r varies from 1 to n. Now we have just found that tr is nothing but 4r square minus 1. When we found it in terms of n, but that is equivalent to writing in terms of r. So breaking this particular summation, we can write as 4 into summation of r square, as r varies from 1 to n, minus summation of 1 as r varies from 1 to n. So writing the formula for summation of r square, we have n into n plus 1 into 2n plus 1 whole upon 6 minus summation of 1 done n times is nothing but simply n. Okay? So therefore on cross multiplying and simplifying, finally we will get the answer of Sn as n into 4n square plus 6n minus 1 whole divided by 3. So this is the final answer.